Civil site design now includes tools that allow users to create reports referencing their design data that can be outputted to an Excel spreadsheet. Alignment, vertical profile, cogo points, and many other types of data can be exported. The cool thing about this new tool is data from an Excel spreadsheet can be used to also drive your design. For example, you could edit the radius of an alignment in the Excel spreadsheet and sync that data back to civil site design. Or crossfall data for a code could be edited in Excel and then synced back onto your road design section. For creating Excel spreadsheets, the Excel export command is used. Excel link is used to drive your design by referencing an Excel spreadsheet. The Excel editor is an inbuilt editor that allows users to edit Excel spreadsheets directly in civil site design. The sync links command is used to update design data that is synced to an Excel spreadsheet. So if you did edit the radius of an alignment in Excel, then you would use this command to sync that change back onto your civil site design alignment. Let's take a look at Excel export. So this is the interface for Excel export, and I've already set up an export process here. To create an export process, all you need to do is click on this button with the green plus. The export process stores a collection of workbooks, sheets, and actions. So on the left hand side are the available actions, and we are planning on adding more actions in the future, maybe for exporting subgrade or volume information. We can see for the cogo point object, the data that we can output. Alignment objects is a list of the actions for those, vertical profile, and design data, which includes things like variations and templates. So that information can be stored in an Excel spreadsheet. So once you've created the export process, you then need to set up your workbook. And if I just edit this one that I've already set up, what you need to do is specify the location for the new Excel spreadsheet. Although you could also open up an existing Excel spreadsheet and tell the software to store information in that. Then you set up the sheets. If you did open up an existing workbook, then this would be automatically populated. But you can add sheets by clicking on the green plus here. So the process after that is to start to add actions. And so I've already done this. I've got data for my alignment, vertical profile, crossfall for my LEB and REB codes, and the width for my LEB and REB codes as well. So when you add an action in, you need to firstly tell the software what sheet they'll be added to, and you can change the sheet here if you want. And then what you need to do is tell the software where that data is positioned on the sheet. So for the XIP here, I'm adding the data from column A, road 1, and that data will be displayed vertically. If I open up that action, you can see what we need to fill out here. I've also got show heading ticked on, so the heading will also be reported in the Excel spreadsheet. So we can see the alignment that we're attaining information from. You can pick a chainage range, and then this is where you set the data location. So from A1 vertically is where the data will be positioned in the Excel spreadsheet. And you can change that directly in this table here as well. So let's have a look at the Excel file. To create it, you just click on Run Excel Report. Once the file is created, the software will automatically load that file in Excel if you do have Excel installed on your computer. So let me just rearrange my interface here. So you can see the sheets created down the bottom. For the alignment sheet, we've got the X, Y radius, transition in, transition out, all outputted. We can see the columns, and then they're all starting at row 1. You can see for vertical profile, crossfall, and lane width for LEB and REB. So for LEB and REB, I'm also outputting the sections, which is important, and there's a number of ways to do this. If I just scroll down to actions, you can see the different types of sections you can output. So you might want to output sections using a section list in the software. If you go changes all, then it's all the sections currently on a string. So if you don't want a long list, you can specify a sections list. But for every section, I can see what the current crossfall is for LEB and REB. And at the moment, we're just using the standard crossfalls from the template. So I'm just going to close that down. As I mentioned, we do have an inbuilt editor, and I can open up the Excel file by going to Excel Export, Excel Editor. By clicking this button, I can open up the editor directly for this workbook that's currently selected. So using the editor, you can view the sheets, and you can also make changes to the data and click on Save Workbook. And you can see that Run Excel Link is checked on. I'll talk about Excel Link in a sec, but this is the idea of any change that I make can be put back onto the objects in Civil Site Design. So this is the spreadsheet editor. By clicking on this button, we can open up the workbook in Excel, as I said, if you have Excel installed on your computer. So that pretty much covers most of the Excel export. So the idea is you create a process, you set up your workbooks, sheets, and then you simply add actions and tell the software where that data is positioned and what sheet it will be put onto. If you have gone to the effort of creating an actions list like this, then you can export this action list to file and maybe use it on another project. You do that by running import action list. And when I run import action list, I can actually specify the codes and the alignment in the other job that I want this action list to reference. So that's a look at Excel export. Let's have a look at Excel link, and I think this is where things start to get really cool. However, you might just benefit from using Excel export to create some reports. The next level, I guess, is linking design data to an Excel spreadsheet. So I've got something already set up in here. I'm specifying a workbook that stores profile data for this road called Coffs Road and this road called Bell Road. And if I just click on edit, this is the location of the Excel file. And if I open up the file, we'll do it in Excel. I've got two sheets, one called Coffs Road, one called Bell Road. And then we've got a list of IPs, the chainage location of those, the level, and the VC length. So I could make a change to this data in here now if I wanted to, and all this information will be synced back onto my profile. So I've got two actions set up, and I will explore some of the other ones in a sec. But this one is vertical profile control. And if I double click on the first entry, what we're saying is from this workbook that I set up, from Coffs Road sheet, the sheet Coffs Road, I want to control the vertical profile of Coffs Road between these changes. So then what you need to do is you need to tell the software where we're getting the data from. So where are we getting the changes for the IP, where are we getting the levels from, and where are we getting the IP links. So from column B, column C, and column D, all starting at row 2. So if I go and open up that Excel spreadsheet, we can see we're getting the change data from B, the level from C and the VC length from D. And we're starting from row 2 because row 1 is the heading. Okay, so you need to set that up and tell the software where we're getting this information from. Once we know that, then it's pretty straightforward. So I've got the same setup for Bell Road as well. So if I open up the vertical grading editor for Coffs Road, this is the standard profile that gets put on when you first create the road. But if I click on Run Excel Link, then you can see that new design has been added there. Let's make a change to the vertical profile, and I'll do this via the inbuilt editor. So let's have a look. I've got this VC length here, 56.255, this one here. Let's make that 150. So I'm editing that cell, and then if I go Save Workbook, you can see it's updated on my profile. So it's saved the Excel file, and then because Run Excel Link is turned on, then that data has been put back onto my profile. Now the thing with vertical profiles is I can also hit this refresh button here to update and resync the data from the Excel file. Now when you do add these actions in, there is this column here called update type. So it tells you what will invoke an update on that object. And for vertical profiles, the update occurs when the auto profile for a string is calculated, which is really what that refresh will do, is update the auto profile information. So that's an example of using an Excel spreadsheet to control vertical profile data. And the cool thing is you might store multiple vertical profiles to file, maybe different options on different sheets in an Excel file, and then decide to sync a particular design back onto your string. Where things could get really cool is you could actually use Excel to come up with a design. So maybe you know how to sort of create some formulas and that type of thing. In the office, one of my colleagues created an Excel spreadsheet that automated a retaining wall. So it'll be interesting to see what users can come up with this new functionality. Okay, so let's I'll just close that, and what I'll do is I'll delete these actions, delete the sheets and the workbook, and I'll start from scratch. So we before exported an Excel spreadsheet called Coffs Row, which had the alignment data, vertical, crossfall data for LEB and REB, and widths for LEB and REB. So I'm going to set up a reference to that Excel spreadsheet. So what I do is I go and add the workbook in. So I'm going to open up this file because it is existing. This is the file here. Okay, you can see it's read the sheets in for me. So I could do this manually. So if I wanted to set up a control to the alignment, I could go and click on alignment control and tell the software what columns to read and what sheet to read it from. But just like Excel export, you can set up an actions list. So you might have a pre-set up list of actions here. So I'm going to go to import action list and select one I've already created. Now when I do this, the software is telling me from that actions list, do I want to change the alignment that we're referencing, or change the string or the code we're referencing, and I'm going to use the data as saved in the file. So this was already set up for Coffs Road, so I'm not going to override the objects being referenced. So I click OK, and these actions are in. So let's have a look. So we've got control alignment, and we're just telling the software what sheet to read the information from, where the easting and northings are for the IP, the radius for the IP, the transition in and transition out. Once we've got all that set up, then that Excel spreadsheet can be in control of that object. Same with the vertical profile, although I'll tick that off because we already played around with the vertical profile. Code crossfall, the software needs to know what column stores the section data and then what column stores the actual data, in this case the crossfall, and the interface will be very much the same for width as well. So pick the string, pick the code we're controlling, the method, are we taking that value from Excel and setting it, so we're setting the width, or are we incrementing the width? This is very similar to what you'll see in some variations in the software. So by running Excel link, the software will update the objects in the software by referencing the Excel data. So let's turn off these actions for now, and then we'll concentrate on the alignment. So I've got this alignment, CSD alignment. Maybe I want to edit the radius here. So I'll use the inbuilt editor to do this. And I'm pretty sure that's the radius of this alignment. Let's see. So let's just go, currently it's 100, but let's make it 150. And then we'll go save workbook. All right, so you can see that alignment is updated. And because the alignment has updated, there's a string there, the software's also resampled that alignment to update our string and section information. So pretty cool. I could have made that change in Excel and then ran sync links. Let's make it say 180. So workbook. All right, you can see that's updated. So there's a few other things you can do in this spreadsheet editor. I don't want to, we didn't want to create a new Excel editor that does everything Excel does, but you can add formulas in to here. We do support a few hundred formulas. You can go and insert extra columns and rows as well. You can select multiple entries and perform edits too. So let's close that down. So I'm going to turn off control alignment because I've made some changes there. And let's go and control the crossfall and the width of the code. So let's start off. I'm going to open up cross section. So I'm opened up at 430, and we can see the current crossfall here. And maybe I'll go and show the offsets as well. So open up the inbuilt editor. This time I'm going to go to the crossfall sheet, and the section I'm editing is 430. So let's just go down to 430 where the current crossfall is -3, but let's just make that on the left hand side, let's make it -4 and then go save workbook. You see that change has happened. Now I could maybe the next few changes I wanted to override to -4. Maybe let's go -3.5. So I can select multiple cells here, and let's just go -3.5, apply, and then go save workbook. All right, so then the next few sections are now -3.5. With things like crossfalls, I mean, users could create their own super elevation calculations in Excel and then take those results and put them back onto the designs. There's lots of cool things I think users will be able to come up with. Let's make a change to the width. Works in a very similar way. So I've got the current width, so we're looking at 460. Let's just go to 460, and the width is currently -3.5. Let's make it -8 and go save workbook. All right, so you can see now it's now -8. And as I said, I could have made that change directly in the Excel spreadsheet, and then by clicking on sync links, that update would have happened. So you can see with the sectional edits, the update occurs from the Excel spreadsheet when the string is recalculated. But it's easy sometimes just to come in and run either Excel link or sync links to ensure that that information from Excel is put back onto your design. So there's a few other actions. You can control cogo point data, maybe property information of a cogo point. You can even have an Excel spreadsheet that has variations in it. You can make edits to the variations, even add new variations, and then sync that back onto your variations in the design data. You can even use Excel to control templates. Look, there's a lot of cool things you can do that I haven't explored in this video, but certainly we'll aim to make some new videos showcasing just some of the cool tricks you can do with this new Excel Connect. So thanks for watching this video, and I hope that you get the chance to explore these new tools in the software, and I think that they're pretty cool. I'm really interested to see what users will be able to come up with these new commands.